here we have problem 6.1. This is just the beginning, kind of foundational building block. Kind of starting to use the touch sensor. It's attached to port 1. We have our normal speed, our set speed if the sensor is on or off, creating a true if that is equal to, if that is true for 1, then the set speed goes through. If not, we go into the built-in function here. So we start using a persistent state. So the state variable is able to change throughout, and it is remembered. So the state button we use, we alter it here by pressing the button. So if the button is pressed, the state is gone up by 1, and then we use it as a remainder if you could divide it by 2 and there's no remainder. That means that the speed is set to the set speed, which is 10. Otherwise, with the else statement, the speed is equal to 0. Then I have 6.3 up here, but it is the same mapping as 6.2, so I'm going to leave it up for visuals. This time we alter the function a bit. So our output here is speed. We have the button and set speed as the inputs. So again, we have a persistent state, but this time we're trying to make sure that the state is changeable in a way that we can modify it in 6.3. So the end goal here is that the function does the same thing, it's just worded a little bit differently. And so initially the state is equal to 0. If that is true, the state is equal to 0. If not, nothing changes, because at the end of this, the state will possibly be equal to 1. So that will not be true, and the state will not be just reset to 0 each time. And so here, we start getting into elseif statements. So if the state is equal to 0 and the button is pressed, button value is either 0 or 1. The value only changes when you do press it, and it's 1. And so if you do press the button, the state changes, or is then changed to 1. Otherwise, else if this statement is not true, which is this little comment here, you skip that part and you go into this else if statement. If the statement is equal to 1 and the button value is greater than 0, the state is then changed to 0. And so after you go through this, either one of these statements will be true. And then if the state is equal to 0, speed is equal to 0. Otherwise, the speed is equal to the set speed, which is 10 in this case. So learn the button is very faulty. Sometimes you hit it, it'll work. Sometimes it won't. Then we have problem 6.3. And it's very, very similar to 6.2, where we have the speed output is equal to the function of the button and set speed. Again, we're using the persistent state to carry over and have values change throughout. And so, after the initial state is equal to 0, which that will always be true once you restart the program, we're trying to work with the robot being able to move backwards, which we'll see later. But if the state is equal to 0 and the button value is greater than 0, the state changed to 1. We skip these two statements and we go down to here. And that would be skip the first statement, because the state would not be equal to 0, and the state would be equal to 1, so the speed would then be the set speed. The robot would start moving forward, Okay, then we go back up to the top. The state is now equal to 1. This first if statement is not true. It is not, the state is not empty because it is equal to 1. We skip that, no different changes. And then if state is equal to 0, it is not. We skip, we go to the first else if statement. The state is equal to 1 and the button is pressed, then the state is going to change to 2. You skip this final else if. If state is equal to 0, no. If state is equal to 1, no. Otherwise, else state is equal to 2 and speed is equal to -1 times the set speed. So we don't have to set a negative speed, or sorry, the negative speed is built in to go backwards. You know, we don't have to add an extra input. And then we go back up to the top. Is the state empty? No, it's equal to 2. If state is equal to 0, no. Else if state is equal to 1, no, it's not. Else if state is equal to 2 and the button is pressed, yes. So in that case, if we press the button again while it's in state 2, the state will go to 0. And then we end that subfunction, and then we have if state is equal to 0, speed is equal to 0, that statement would be true, and the robot would stop moving, and we skip these last two statements.